Hi, welcome back. So for this video I will be growing seeds in microgravity to see how they orient themselves. This time I will be growing tomato seedlings, and to make everything look clearer, I will be growing them on agar in petri dishes, let's say 25 per petri dish, and I will be growing 4 samples, one on the clinostat with light, one on the clinostat without light, and of course 2 controls with and without light. Now the reason for this is that the plants can either orient themselves towards the light or against gravity, so the plants on the clinostat with light or on the ground without light will still be able to orient themselves, at least partially, but the plant on the clinostat without light will have problems. I'm using the same schedule, 14 hours of light followed by 8 hours of darkness, but this time I suppose it'll take a week, maybe 10 days. I just borrowed the PAR meter from the university. PAR stands for photosynthetically active radiation, which is the amount of light between the wavelengths of 400 to 700 nanometers, which the plants can use the most effectively. It's measured in micromoles per square meter per second, and the PAR of sunlight is usually between 400 to well over 1000 micromoles per meter square per second, but it varies with latitude, with the amount of clouds in the sky, with time of year, and so on. Now for the PAR of my lamps, let's say 10 centimeters away from the lamp, this should be around 250 micromoles. 500 will be maybe 3-4 centimeters away from the lamp, and at the level of the lamp this will be around 750. Now if I move it away, it goes down a bit, but it's fine. So it's not as good as natural sunlight, but for my experiments it's pretty good. I just came home and found out the seeds are finally sprouting, which makes me so happy because it's been 5 days and I've been really starting to worry that I did something wrong, that the seeds will just not sprout or they will die. You can see one root right here. Of course, on the plant from the clinostat, if I can get it to stop flickering. There's one right here. It's now day 8 and the first leaves have emerged from one seed. You can see it right here. If I can focus, yep. It happened just a few hours ago, so the leaves hadn't had time to orient themselves properly towards the light. But I have to say, the plants have been growing slower than I expected. Also the control samples. Now this might just be because I made the agar thicker than I had to. I didn't know what the right consistency should be, so maybe the plants have just more troubles getting the water from the agar itself. But one interesting thing to notice is that the roots, even when they start growing towards the light, they keep growing in a straight line. You can see it right here, for example, which means they don't respond to sunlight, they only respond to gravity. They cannot orient themselves away from the sunlight, only towards the gravity, and since there is no gravity, they continue growing in a straight line. It's now been 14 days. I left it on for longer than I initially thought, but let's turn it off and look at the results. Here are the 4 samples. Let's see how the ones from the darkness turned out. I noticed it was a bit colder in the darkened part, but I'm hoping this didn't change the experiment too much. Let's see the one from Earth's gravity first. In the presence of gravity, the plants were still able to orient themselves with the roots towards the ground, towards the gravity, and with the shoots against the gravity, but they are so long and thin because they attribute the lack of light as a sign that they are still under the ground and try to reach the surface and the sunlight as soon as possible, as fast as possible. You can also see the leaves are very pale yellow. This is because the chlorophyll is only produced after the plants get sunlight, and if they don't have sunlight, they put all the energy into growing as fast as possible towards the surface of the soil. Now when the plants don't have gravity or sunlight, it looks to me as if the plants were actually stretched more than in the presence of gravity and absence of light. But you can still see some plants are still oriented towards the agar, basically towards what the ground should be for them. So they cannot attribute the presence of agar as a sign of gravity. So to sum up, in the presence of light and gravity, the plants grow perfectly normal. In the absence of gravity but presence of light, they grow basically still towards the light, but the roots have slight problems orienting themselves. In the presence of gravity but in the absence of light, they grow etiolated, which means stretched without chlorophyll trying to reach the surface, but they can orient themselves towards where surface should be, and the roots grow normally towards the gravity. And in the absence of gravity and sunlight, they basically don't know where to go at all. They are very etiolated, and both roots and shoots have problems orienting themselves. Here are the cross sections through the stems of the plants that were grown in the light. On the left you can see the sample from the clinostat, and on the right the control sample. You might be able to see that the cells from the plant on the clinostat do appear shorter in length, but are wider. But it's quite difficult to see. It was difficult to get a good cross section. And cross sections through the roots as well. You might be able to see some difference in the dimensions of the cells, but nevertheless I expected more of a difference. I expected the cells from the plants on the clinostat to be much more round and not so elongated. But the important part is that the plants are still able to grow properly even without gravity. In a few weeks, I will be growing a plant in microgravity from seed once again, but this time for longer to see how it affects it throughout the entire development. See you then!